Today we're going to look at another way of writing equations of a line. So let's get started. There are three main ways, or forms, we can use to write linear equations. As a reminder, the graph of a linear equation is a line, a straight line. We have already looked at the slope-intercept form and the point-slope form, and we saw that just by looking at an equation written in either of these forms, we can get some information about the line. For both forms, we can find the slope of the line, which in these two equations is indicated with the m, and we can also find a point on the line. For the slope-intercept form, this point is a very specific point. It's the y-intercept, so where it crosses the y-axis. For point-slope, it can be any point that is on the line. Now with this third form, or standard form, we can't get any information about the line just by looking at the equation. And today we're going to look at the standard form of a line. It is commonly used, and we will see it a lot when we start looking at systems of linear equations. So let's look at the advantages and limitations of standard form, what it's good for and not so good for. So the standard form of a linear equation is ax plus by equal to c. So in standard form, the variables x and y are both on one side of the equation with their coefficient, and then a constant is on the other side of the equation. Now, if you remember, with the slope-intercept form, we used b to represent the y-intercept. So now we have a lowercase b for y-intercept and a capital B in the standard form. Now these two are not related. There is no connection between these two letters. Even though we're using a lowercase b in slope-intercept and an uppercase B for standard form, and we're talking about linear equations, there's no relationship, there's no connection between these two. So in standard form, A, B, and C, well, they're going to represent, ideally they represent integers. So we have something like 2x plus 9y equal to 18. So in this case, A is 2, B is 9, and C is 18. And again, ideally, we're just going to have integers. But at a minimum, they have to be constants. So sometimes you may see something written like this, where we have this fraction, 2/3. This is not an integer, but it is a constant. It's a number. But we can rewrite this so that it's only integers. So to do this, we need to get rid of this denominator. And we can do that by multiplying by the denominator, in this case 3. So if we go 3 times 2/3 x plus 3 times 3 y equal to 3 times 6. So multiply everything by 3. Well, this is 3 over 1. So those 3's are going to cancel. We end up with 2x plus 9y equal to 18. And so that is the same equation here. So if you're given an equation in standard form, but the coefficients are not all integers, you can convert that into a standard form where all the coefficients are integers. Another thing with standard form is that A and B cannot both be 0. So let's set A equal to 0. So with this equation, 2x plus 9y equal to 18, I'm going to make A 0 instead of 2. That'll give us 0 times x plus 9y equal to 18. Well, 0 times anything is 0, so that's going to go away. Now we have 9y equal to 18. We can rewrite this as y equal to 2. And this is a line. This is a horizontal line. Now if we do the same thing, but in this case we let b equal to 0. So we'll take this same equation. We'll have 2x, and then instead of a 9, we'll replace this with a 0. So we'll have 2x plus 0 times y equal to 18. Again, anything multiplied by 0 is 0. So now we have 2x equal to 18. And this is x equal to 9. And that's okay, that's a line. That's a vertical line. But what happens if both a is equal to 0 and b is equal to 0? Well, now we have 0 times x plus 0 times y equal to 18. Well, that one's going to go to 0, and that one's going to go to 0. So we have 0 equal to 18. And that's not true. So a can be 0. We saw that in this first case. We end up with a horizontal line. B can be 0. We saw that in the second case here. And we end up with a vertical line. But we can't have both a and b being 0 at the same time. And then finally, a should be positive. Ideally, that first coefficient will be a positive number. Oftentimes, if you have a leading negative, so negative 2x minus 9y equal to negative 18, these leading negatives can get lost sometimes, get dropped. But all you need to do is multiply everything by negative 1, and you end up with a positive a coefficient, and then the signs of everything else will switch. So what is standard form good for? Well, standard form is really good for finding the x and y-intercept because the math is somewhat easy. So we've looked at the y-intercept before. And when we have a y-intercept, the x value is going to be equal to 0. So our ordered pair, the x-coordinate is 0, and then we get some number for the y-intercept. So to find that y-intercept, we're going to set x equal to 0. So we have 6 times 0 minus 7y equal to 42. Again, when we multiply by 0, it becomes 0. So we have negative 7y equal to 42. And then to get rid of that multiplication by 7, we're going to divide by negative 7. What we do to one side, we have to do to the other. We end up with y equal to negative 6. So our y-intercept is the ordered pair 0, negative 6. Now with the x-intercept, this is where it crosses that x-axis, so it's not going up or down. And so our y-coordinate value will be 0. So the ordered pair is going to be some number where it crosses the x-axis, and then the y-coordinate will be 0. So if y is equal to 0, we have 6x minus 7 times 0 equal to 42. Again, 7 times 0, that's going to be 0. Now we have 6x equal to 42. We want 1x, so let's go ahead and divide by 6. And we end up with x equal to 7. So now we have the ordered pair 7, 0. So standard form is useful for finding the x-intercept and the y-intercept of a line. And with those 2 points, we can graph our line. So our y-intercept, again, that's where it crosses the y-axis. That's at -6. And the x-intercept, that's where it crosses the x-axis, and that's at 7. And then we can connect those points to draw our line, graphing the linear equation 6x minus 7y equal to 42. In this problem, we're going to find the x-intercept, the y-intercept, and the slope of the equation 6x minus 7y equal to 42. Does this look familiar? So this is the same equation we were using in the previous example. So we've already found the x-intercept and the y-intercept for this equation. So how did we find those? Well, we set x equal to 0 and found the y value to get the y-intercept, and set y equal to 0 and found the x value to get the x-intercept. And so that gave us our x and y-intercept. So now let's look at finding the slope. And we can do this in a couple of different ways. We have 2 points. So we can use that formula for finding the slope of a line when we have 2 points that are on that line. So that's the change in y over the change in x. So when we substitute in those values, we'll have -6 minus 0 all over 0 minus 7. This is -6 over -7, which simplifies down to 6/7. Now when we look at this equation, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, what we're doing is we're finding the change in the y value all over the change in the x value. Another way of writing change of a value is using the Greek letter delta. It looks like a triangle. So we'd say the change in y value all over the change in x value. Again, so this triangle here, this is the Greek letter delta. It's actually the capitalized version of delta. And even the lowercase version, which looks like this, is often used to indicate a change in something. So if we look at our table and we start at point 1 and we look at the change going from point 1 to point 2, while looking at our y values as we went from point 1 to point 2, our delta y, well, that's equal to 6. It increased by 6. We do the same with our x values going from point 1 to point 2. Our delta x, our change in x, was 7. So now we can look at slope and say, well, delta y all over delta x, that's equal to 6 over 7. And this is the same value we got when we use the formula for the slope of a line when we know 2 points on that line. Now when we move into calculus, this delta y, delta x, that's slowly going to become dy over dx. And again, we're still looking at kind of a change in y and a change in x. But we'll look at that much later. So here's one method of finding the slope. Here's a second method for finding the slope. Now let's look at a third method for finding the slope. Well, if we have the equation 6x minus 7y equal to 42, we can rewrite this equation in slope-intercept form and find that slope. So to do that, we need to get y by itself on one side. So let's get rid of this 6x. We'll do that by subtracting 6x from both sides. Now we have -7y equal to -6x plus 42. And then to go from negative 7y to 1y, we're going to divide everything by negative 7. So now we have the equation y equal to 6/7 x minus 6. And then from here we have our slope, which is again 6/7. And we can also see our y-intercept. And then a fourth method for finding that slope is to use the graph. And we can calculate our slope with our rise over our run. So again, starting at that first point, we're going to go up 1, 2, 3, 4, 5, 6. So we went up 6. Our rise value was 6. And then run was 1, 2, 3, 4, 5, 6, 7. We went to the right 7. So we now have 6/7. So 4 different methods, at least, for finding the slope of this line. You only have to do one. So with standard form, although you have a lot of options, you do have to do some work in order to find the slope of a line when the equation is in standard form. It's not as apparent as when the equation is written in either slope-intercept form or point-slope form. So the standard form may not be so good for finding the slope of a line, but you still can. A great way to learn is practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 2 problems. Okay, so for these 2 equations, we're going to find the x-intercept, the y-intercept, and the slope. So to find the x-intercept, we set y equal to 0 and solve for x. For the y-intercept, we set x equal to 0 and solve for y. And then you have a couple of options for finding the slope. We can use that formula we've been using, where the slope is equal to y sub 2 minus y sub 1, all over x sub 2 minus x sub 1. Or we could look at that table we may have made to find the difference in the x value and the y values. Or we can convert that line into slope-intercept form. If you did convert it to slope-intercept form, this is also a way of getting that y-intercept. So you could potentially skip this step here. Either way, we end up with an x-intercept of 9, a y-intercept of 2, and a slope of negative 2/9. We'll do the same process with this second equation, 12x minus 4y equal to negative 36. Again, to find the x-intercept, set y equal to 0. For the y-intercept, we're going to set x equal to 0, or if you plan on finding the slope by converting that equation into slope-intercept form, you can also find the y-intercept from that equation. And then to find the slope, again, you can rewrite the equation in slope-intercept form, or you can find the difference in the y values and the x values to find the slope. You'll end up with an x-intercept of negative 3, y-intercept of 9, and a slope of 3. Feel free to drop any questions you have in the comments. Continue practicing working with standard form, and I'll see you in the next video.